Hi everyone. In this video, we are going to discuss this access control list. So before giving formal definition of access control list, let's briefly discuss that what actually happens when a router receives a frame, then what actually router has to perform. So for example, in this scenario, this user generated a packet, encapsulated it in a form of frame, and then this forwards that frame to some of the interfaces of the router. Now, router will receive that frame, will de-encapsulate that packet, and will look into the IP address. And on the basis of IP address, it will forward that packet to the next router. In this way, the next router will receive. And again, the next router will again de-encapsulate that packet, will look into the IP address in the header part of that, and it will forward that packet to the next router, or that frame to the next router, to be specific. So in this way, this frame will be received at the ultimate destinations, and this is how a router is going to process these frames. Now, to be specific, what we saw, so actually when the router receives a frame, it de-encapsulates. It de-encapsulate means it will remove this Ethernet header and Ethernet trailer part from that, and then it will check the IP address in the header part. So you see in the header part we have this source IP address, destination IP address, maybe port number. So we have different fields in this IP header part. And by looking at that, it takes a decision on the basis of routing table, and it will forward that. So this is the routine job of a router. Now, what we can do, so we can actually assign one more job, one additional job to this router. So we can actually configure these routers with some list of instructions, or with a list. And on the basis of that list, we can ask the router to discard packets from some particular node or some particular computer. For example, in this case, we can ask this router that as soon as you receive maybe packet from this host, then maybe deny it or maybe allow it. So in this way, we can configure a list there. So in this way, we can have, for example, this list. So we can configure a list like this on this router or this router, or on every router. This depends on our requirement. So in this case, what will happen when a packet will be received, a frame will be received, of course. So in that packet, after de-encapsulation, the router will look into the header, and on the basis of the information in the header, it can discard it. So this is one of the options. Or maybe on the basis of the information in the header, maybe the IP address, it can also forward that packet or that frame to the next router. So in this case, it is going to make decision on the basis of the instructions we provided in the form of a list. Now, that list with instructions to the router is known as access control list. That means access control list has some instructions by which we ask the router to maybe forward some of the packets and maybe to drop out some of the packets. So we want to drop out some of the packets which are maybe from a bad guy. We don't want to entertain that guy, and we are asking the router to just discard those packets. And this is the reason that we make these ACL, or access control list. So control list is also known as a filter. And the filtering decision, or the filter, or access control list, makes a decision on the basis of, for example, the source IP address, destination IP address, protocol like TCP or UDP, SMTP, and it makes decision on the basis of port numbers. So for example, HTTP, we have port number 80, the same way FTP, Telnet. Now we have two types of access control list. One is known as standard access control list, and then second one is extended access control list. So this standard, in a standard access control list, we actually use numbers, but that can also be by using the same principle, we can also name it. So we can create the same standard access list as a named access list with same functions, and extended as well. So extended access control list can also be created using a named access control list, but the job will remain same. Basic principles is same. That we'll be looking at that in the next slide. So if we discuss this on a standard or named access control list, what happens in this standard access control list, the filtering decision is made on the basis of source IP address. So what happens here, when the router receives a packet, it will look into the header part and it will make decision on the basis of source IP address. So it will say source IP address, and if it matches, for example, if we have a list here and we say that please block the packets from some specific IP address. If we say from this IP address, then it will just look at the source IP address, and if it matches, then it will take the decision. And what decision? So we will provide the decision that if the packet is coming from this guy, maybe deny it, and for rest of the guys we can say yes, permit rest of the guys. So we can do it. So it will check the IP address, the source IP address, and it will make decisions. So this kind of access control list is known as standard access list, and we can create, by using the same principle, we can create the named access control list, where instead of numbers we will have names. So I'll mention this. And if you look at the OSI model, then standard access control list actually match packets on the basis of layer 3 source IP address. So we say that this will make decision of layer 3 because it will only check the IP address, and IP address is actually network layer issue. Then we have extended access control list. So in this extended access control list, the filtering decision is made on the basis of source IP address, destination IP address, protocol, and then port numbers. So now we have more options to make decision on whether to deny a packet or whether to permit a packet to pass through this router. So what happens here, when the router receives some packet, it receives frame and de-encapsulates it, and then it has the packet. It looks into the header part, and in the header part it will check the source IP address, destination, port number. So it will check multiple options, and after checking these multiple options, it will make decisions. It means now router is performing in efficient way. It's not using one criteria, it's using multiple criteria to make decisions. Then it can, on the basis of that, it can forward or discard that. And if you talk about on OSI model, if you want mapping, then we can say that extended ACLs match packet based on layer 3 and layer 4. Layer 3 means source and destination IP address. Layer 4 means these port numbers. These are actually, these are layer 4 information. Then if we talk about this standard access list, so actually standard access list follows instructions like that when you receive a packet, look into the header part, and if the source address matches some specific particular IP address, then maybe we can say that please block them, or maybe we can say please allow them. So we can say like that as well. So for example, in this case, we have configured this access list, which is a rough access list on this router, and we say that if the source address is this one, say 192.168, then please permit them. So if you receive this, then allow them, receive them, and then allow them or forward them. But if you receive a packet and if the destination address is this address, then please do not allow them and you just discard them. Now in this access list, the specific instructions are called access control entries or access control statement. It means this is access control entry. This is also an access control entry. So we have multiple access control entry, just giving specific names to them. And if we have multiple entries in the access control list, then what happens? Each entry is matched sequentially from top to bottom. So in this case, we have only two statements or two entries. So the router will check the first entry first, and then it will move to the next one. And maybe we can have third one. So sequentially, it will check all of them. And once a match is found, maybe it found a match at line 3rd, then maybe 4, 5, 6 line will not be checked. So it will go from top to bottom. Once the sequence, once any matches occurred, it will stop there, and it will not check the rest of the lines there. Now the configuration, how to configure access control list. So broadly, we can divide this configuration into two steps. In the first step, we actually create the access list itself, and we have this command to create access list. So if we talk, so at this time, if we specifically talk about a standard access list, not extended, standard access list. So for a standard access list, we have this command. So we go to global configuration mode. There should be sign of X. In the global configuration mode, we use this keyword access list, and then we give a number. So that number can be from 1 to 99, or that can be from 1300 to 1999. So this is any number we can use from this range. So this range actually identifies that we are using or we are configuring standard access list. So, and then we can say permit, deny, or remark. We have these options, and then we give the specific source IP address for which we want to make some decision. And then once we have created the access control list itself in the first step, in the next step, we apply that access control list to some particular interface of the router. And for that, we need to go to that particular interface, and then you see, for example, here we need to give the name of that particular interface, and then we assign or just apply that access control list to that interface. So whatever number we use here, so for example, access control list maybe 10. So we used one of the number here. So we said access control list 10. So this is the number for that access control list. And here we will use exactly the same number, matching number. It means access control list with the number 10 should be applied to this particular interface. So this number should match. And then we also mentioned whether we want to apply this access control list to the inbound packets or the outbound packets. So inbound packet means when the packet is being received at some interface, whether we need to make decision at that point, or whether we want to make those decisions when the packet is going to exit from some of the interfaces. So at the exit point are the outbound packets or the inbound packets. We can mention this as well as per our requirements. Yeah, one more point which is related and which we need, that is matching addresses with the wildcard. So wildcard mask actually instructs the router that which part of the IP address needs to be checked. So for example, what happens here, we have one access control list, and in that access control list, we have used this keywords and we have used this access control list, maybe number is 1. And then we say permit this specific IP address, one particular IP address. We want to permit only that IP address. Now, with this wildcard mask, so what happens, sometimes maybe we want that instead of matching all these octets of this IP address, we have 4 octets. Instead of matching all of them, we can instruct the router that just please match these 2 octets and do not match these one. So as soon as you receive some packet, and that packet we have the IP address, you look at these initial the first 2 octets. If they match, then start making decision and make decision and forget about these remaining bits. Now, how to convey this information to the router? For that purpose, we use this wildcard mask. So for example, in this case, we can say that when you receive a packet, look at the header part, and in the header part you will find IP address, and then in that IP address match only the first octet. So match that this octet, this part must match, this part must match, and this part must match, and forget about the last octet, whatever value is there, forget about that. If only these three octets are matching, then make decisions, and that decision can be of deny or accepted. So this is the reason that, and this zero means, this zero indicates that you must check that part. So this zero means when you are checking the IP address in this header part, the first octet must match, the second octet must also match, and the third octet must also match. But this 255 means ignore the fourth octet. Okay. And for example, in this case, we have been given this IP address. We have this IP address, and this is subnet mask. So the question is how to find out this wildcard mask. So wildcard masks are actually found by inverting the subnet mask. So for example, in this case, we have this subnet mask. If we represent that subnet mask in binary, then this will be the subnet mask as a binary equivalent of this subnet mask. And then to find out the wildcard mask, we invert these all respective bits. So this one will become 0, this one will become 0. So you can see these all will become 0, this all will become 0, these all will become 0, and only this part, they all will become 1. And then we convert this into decimal notation. So this will be 0, this will be 0, 0, and this is 255. So this is what we have used here, you can see. And even if we have this decimal format, so we can work directly in decimal. So what we do, we take this subnet mask and we subtract this subnet mask from, maybe sometimes this is known as a global subnet mask. So we have 255, 255, or 255 at all these 4 octets, and then we subtract the subnet mask from that, and whatever answer we get, that will be our wildcard mask. So we use the same wildcard mask here. So you can see we can get this wildcard mask using binary notation as well as the decimal notation, the decimal format of numbers. And then we have one deny all or permit package. So one interesting thing is that by default, the router uses deny any at the end of any ACL. So if we create, for example, if we create an access control list, by default, the router IOS adds one line there at the end, and this says that deny any. Deny any means whatever, if no condition is matching, then the last condition is that deny all the packets. So by default is that. And in some situations, we want to change it, so we can say, so we can also use. So this is last entity instructs the router to deny all packets. This is by default setting. So this is, I mentioned there. So if we can have one statement or one entry, then second entry, but the last entry will be that deny any. But we can override this by using, say, permit any. So if we use permit any, it means, if we use permit any, it means now we changed this setting there. So this will actually, I mean to say, this will stay there, but permit any means before going to this line, we have used maybe permit any. So this will permit the packets, and this will not go to this next entry. Now just an example, just that how can we configure the standard access list, because I haven't discussed extended access list. So standard access, in a standard access list, if we want to configure in this scenario, so first we need to go to global configuration mode. And then, for example, we want to say that permit packets from this host. So you can say from this host. So this is maybe extra. This should not be there. So permit packets from this host, and to mention specific host, we can actually forget about that. But I just wanted to clarify this point. So in this case, we are explicitly asking the router that please match this one, this one, this one. So actually, in a standard access control list, if we don't give this one, so router will understand that at this time the router has to match all these 4 octets. And maybe we can say that in a second access control list, we can say that we have given you the IP address, but this time you just need to match the first octet and then maybe ignore the rest of the octets. So whenever you receive a packet and if you see the first octet like this, then make decision. Make decision means permit them as per this instruction. And then once we have created this access list, so this is the first part. In the second part, what we do, we apply that access list to particular interface. So with this command, we went to that particular interface, in this case S00/1. And then we use this command, that's IP access group, and this is the access list 1 should match. And then we want to use this to inbound package. So this is how we can apply that one. And finally, we can see these access control lists in our IOs. So we can use some show commands there. The first one is show IP access list. This command actually lists details about all these IPv4 ACLs only. But if you use this general one, then this will display all the ACLs there. And then we can also see the ACL applied to some particular interface. For example, in this case, this is serial interface. Then by using this command, we can actually see the ACL applied to that particular interface. So these were some brief introduction about standard access control list, but we didn't discuss the standard control list. So we will discuss as well as apply these ideas in the packet tracer, where we'll be further discuss these things. And yes, in the end, thank you. Thank you very much for your time, and I hope this was a bit helpful for you. Thank you.